students, I am Sachitrakar. Welcome to Cars Physics. I am going to discuss kinematics and this is my lecture 1 on kinematics. Okay, and we will start under kinematics motion along a straight line. Okay, before discussing the subject, I like to say kinematics will contain a number of lectures, means this will be a long series. Okay, but I commit, I'll discuss in details the theories as well as I will show the application of theories to answer different levels of questions and to use the mathematical formula to solve problems which will be useful for your regular studies as well as for future competitive exams. Okay, let's start. Before going to kinematics, let's discuss the unit mechanics. Okay, mechanics is the branch of physics which deals with rest and motion of a body or a system of bodies as well as the study of cause of motion. Okay, mechanics is a larger part in physics for clarity, for clear understanding. Mechanics is divided into 3 branches. Number 1, statics. The first branch of mechanics is static. What is static? Static means rest. Okay, if a body or a system of bodies continue to be at rest for some interval of time, then the conditions come under statics. Okay, suppose a body is at rest, it doesn't mean that the body is not experiencing any force. Okay, let's consider with simple examples. Suppose a body of mass m is resting on the surface. Okay, in this case, the body exerts force on the surface due to its weight. Weight is mass into acceleration due to gravity. So due to its weight, it exerts a force on this surface. And obviously, the surface gives reaction that's called as normal reaction. And here, weight of the body and normal reaction are 2 forces are acting on the body, and sum of these 2 forces is 0. Means resulting force acting on the body is 0 and the body is at rest. Okay, this is called as static equilibrium. Okay, let's take another example. Suppose this is a conical container. Okay, this is a conical container and a small spherical body is resting in this conical container. Then how many forces are acting on the body? Number 1, the weight of the body obviously acts in vertical downward direction, and this weight or force due to weight of the body is balanced by the normal reactions from the contact places. This is one of the contact places where the body leans on the surface and reaction starts from this contact point, and let this reaction is R1, and from this contact point another reaction is R2. Thus 3 forces, weight of the body, R1 and R2. 3 forces are acting on the body simultaneously and the body continues to be at rest. Okay, all these discussions are under static. Okay, then second branch, number 2. Mechanics has 3 branches. First branch is statics. We have discussed. Number 2, kinematics. What we are going to discuss? Kinematics. Kinematics is the branch of mechanics. Kinematics is the branch of mechanics which deals with the studies of motion. Kinematics deals with motion but without considering the cause of motion. Okay, kinematics is the branch of mechanics which deals with study of motion, but without considering the agency which produces motion or the cause of motion. Okay, thus under kinematics we do study about motion. Okay, thus under kinematics we are going to study what is motion, what are different types of motion, what are different characteristics of motion, and finally what are the mathematical equations which are used to express motion. And those mathematical equations are called as equations of motion, for which the name kinematics satisfies. What? Kine, the term comes from motion. Matics, the term comes from mathematics. Means kinematics deals with the mathematical equations used to express motion of a body or motion of system of bodies. But in kinematics, we don't study about the cause of motion. Okay. Then final branch, third branch, mechanics is divided into three branches: static, kinematics, and finally dynamics. Dynamics is the branch of mechanics which deals with the study of cause of motion. Okay. Dynamics deals with the study of cause of motion. In later stage, we will know dynamics is of two types: linear motion. For linear motion, linear dynamics. For rotational motion, rotational dynamics. Okay. And the causes are force and torque, which will be discussed in later stage. Okay. This is a small discussion about mechanics. Okay. We will start now from kinematics. Okay? Kinematics. What we have discussed? Kinematics deals with study of motion. Okay. Let's discuss what is motion. In general form, motion means change of position of a body. When a body or when an object changes its position, then this is termed as motion. Let's discuss. Suppose a body is initially at a point A. Okay, it changes its position and moves to another position B. Okay, A is initial position, B is final position. Let the body start its motion when time is 0 and reaches at B when time is t. Thus it is very clear that when a body changes its position, there is some interval of time, means the body takes some time to change its position. If a man starts from his home, this is home, when time is 10:15 a.m. and goes to market, this is market. Okay. Then distance may be measured, maybe a straight line, maybe a curved path. Distance may be measured as 500 meters. And when he reaches, time is let 10:30 a.m. Then time taken by the man to change his position is 15 minutes. Okay. Thus it is clear that to change the position, there must be some interval of time. Okay. Then definition of motion. We'll analyze in brief what is motion and what are different conditions to understand motion. Motion is change in position with respect to a standard point in the surrounding. Okay. Motion is change of position, means position must change to have motion. With time, there must be some interval of time with respect to a standard point in the surrounding. Okay, that standard point is called as reference point. Okay, reference point, that standard point is called as reference point. Reference point is assumed to be at rest without change of its position. This is assumption. Reference point is assumed to be at rest without changing its position. Reference point is selected conveniently in the surrounding. Okay, let's discuss. I am in my classroom. This is my surrounding. Okay, reference point is the standard point. We have to select a standard point which is called as reference point, which should be at rest without changing its position, and it is selected conveniently. Let's consider a point. This is the standard point which is called as reference point. Okay, why I selected this point? This point I have taken on my whiteboard because the whiteboard is fixed on the wall of the building. The building is at rest. Wall of the building at rest. So whiteboard is at rest. So the reference point or the standard point is also at rest. It is selected conveniently, means very closer to me. Okay. To know the motion of a body, we have to select a standard point conveniently in the surrounding, which is called as reference point, and reference point should be at rest without changing its position. So far we have discussed. Okay, if a body is at rest, how? If a body doesn't change its position, if a body doesn't change its position with respect to the reference point, then the body is said to be at rest. Then how can you conclude? Suppose I am the observer who is observing the condition of the body. I have to observe the position of the body with relation to or with reference to the standard point. Okay, if the body doesn't change its position with respect to the reference point with time, then the body is said to be at rest. In other words, if the body changes its position with relation to the reference point, then the body is said to be in motion. Okay, very simple. Okay, then another discussion. If reference point is actually at rest, if reference point is actually at rest, then the state of rest or motion of the body may be called as absolute rest or absolute motion. If reference point is actually at rest and a body doesn't change its position with respect to reference point, then the condition of rest is called as absolute rest. Or if reference point is actually at rest and a body changes its position with respect to the reference point, then it is called as absolute motion. Okay, can you get some point in the surrounding, in your surrounding, or can I get any such point in my surrounding which is actually at rest? No. No point is actually fixed. Why? I have taken the reference point on my whiteboard. Whiteboard is fixed on the wall of a building. The building is moving because the building is on the surface of earth. Earth is moving. All earthly bodies are moving along with earth. So the building is moving, this wall is moving, the whiteboard is moving, thus this point is also moving. But if I say this body is at rest because the body is not changing its position, then how can we discuss it? This body is not changing its position with respect to the reference point, but practically what happens? This reference point is moving, this body is moving, but the body doesn't change its position with respect to the reference point. Okay, this reference point is moving, but a body changes its position with respect to the reference point. So, body is in motion. So, since body is in motion with respect to the reference point, body is at rest with respect to the reference point. So, our discussion will change now. Since there is no such reference point is available, not only on the surface of Earth, but throughout the universe, no such point is available which is actually at rest. Okay. We may say sun is at rest. No. Sun is not at rest. Because sun is in our galaxy. Galaxy is moving, so sun is moving. Okay. So without motion, nothing exists. Okay. Without motion, there is no life. Blood is moving in our veins and arteries. And we breathe because air is flowing during breathing. Okay. So only motion. Okay. Then the conditions of absolute rest and absolute motion are not possible. This is final discussion. Okay. A body is at rest with respect to or with relation to the reference point, or a body is in motion with respect to or with relation to the reference point. So, all conditions of rest and motion are not absolute but relative. Okay. Thus, a body is at rest with respect to the reference point means this body is at relative rest. A body in motion with relation to the reference point, thus this body is in relative motion. Okay, thus final sentence. Absolute rest and absolute motion are not possible since there is no fixed point, no standard point, no reference point is actually at rest or actually fixed. So all conditions of rest and motion are relative, means relative rest and relative motion. Okay. Can a body remain at the state of rest and motion simultaneously? I will discuss this. Okay. In later stage in this class, I will clarify this. This is my question. Think it on. Can a body remain at the state of rest and motion simultaneously? You go on thinking. Then the summarization of all these discussions. The conditions of rest and motion depends upon, this is very important sentence I am writing, you must remember it. The state of rest, or motion depends upon the state of observer and frame of reference of the observer. The state of rest or motion depends upon the state of observer or frame of reference of the observer. Okay? Then we will now going to discuss about frame of reference. Okay? Highly conceptual, and there are a lot of applications on frame of reference in Newton's laws of motion. Means while applying Newton's laws, using frame of reference, we have to consider shadow forces, and where we have to consider shadow forces, we will discuss in laws of motion. Okay. Now, our discussion is frame of reference. Okay. Our discussion is frame of reference. So before going to frame of reference, a fundamental concept which you already know if you have studied vector analysis. That point is Cartesian coordinate system. Cartesian coordinate system, you know it. In your vector analysis, I hope you have already studied it. But I started my lecture from kinematics. Okay? To understand kinematics well, you should be clear on vector analysis and also the mathematical formula, the fundamental mathematical formula of trigonometric, algebra and calculus, means differentiation and integration. I will show the application in my next lecture. Okay, this is only fundamental class about kinematics. Then Cartesian coordinate system. What's Cartesian coordinate system is? Cartesian coordinate system consists of three mutually perpendicular axes meeting at origin. Okay, suppose this is x-axis, this is origin, this is y-axis meeting at origin. See, x-axis and y-axis are mutually perpendicular to each other, and also as I consider here, both x-axis and y-axis are parallel to the surface, means surface of whiteboard. X-axis and y-axis both are parallel to the whiteboard, as well as both are mutually perpendicular to each other. Then let's consider another axis, that is z-axis. Z-axis is in space. Okay, means x-axis, y-axis and z-axis all are mutually perpendicular to each other, but the difference is x-axis and y-axis are parallel to the surface and z-axis is perpendicular to the surface. Okay, but I can't draw such a line which is perpendicular to the surface, means the line is extended in space. Okay, let's consider this is z-axis. Actually, z-axis is in space. Okay, these are three mutually perpendicular axes starting from origin or meeting at origin. Okay, value of x at origin is 0, value of y is 0, value of z is 0, means the coordinates of origin are 0, 0, 0. Okay, then why do you use Cartesian coordinate system? Cartesian coordinate system helps to locate the position, to determine the position of a particle or position of an object or position of an event. Okay, in space, because these x, y and z are space coordinates. Use space coordinates, x coordinate, y coordinate and z coordinate. Let's consider an event or an object is in space. Then the position can be determined by the help of position vector. You know it from vector. Position vector. So what's a position vector? Position vector shows the position of a point or position of an object in space with respect to origin. And direction of position vector is from origin to the position. So I am representing, this is position vector and this is a point in space. Let this position vector is R1. R1. Then how position vector is determined? Position vector is determined by coordinate system. Let this point P is at a distance x with respect to x-axis, at a distance y with respect to y-axis, and at a distance z with respect to z-axis. Okay. Then coordinates of point P are x, y, z, and you know the expression of position vector, that's equals to x vector along x-axis. This length is x, but direction is along x-axis, plus similar way y vector along y axis and z vector along z axis, and in terms of unit vectors you know x I cap plus y j cap plus z k cap. I cap, j cap and k cap are unit vectors along x axis, y axis and z axis respectively. Then magnitude of okay, this is our. Then magnitude of position vector is square root of x square plus y square plus z square. Okay, this is all about Cartesian coordinate system. It contains three mutually perpendicular axes and it helps to locate the position in space by the help of position vector, and this is total expression, vector form and algebraic form of position vector. Okay, thus to locate the position in space we require the system of three coordinates, means x coordinate, y coordinate and z coordinate. Right? Then we are moving to frame of reference. What is frame of reference? Frame of reference consists of a system of coordinates. Frame of reference consists of a system of coordinates whose axes are suitably selected. Okay, the axes are suitably selected. Okay, it contains a system of coordinates. Okay, to get coordinates we have to represent the axes, and those axes are represented suitably. Then how will we represent? First thing, frame of reference is used to describe an event completely. In simpler way, frame of reference helps to describe the motion in space completely. Okay, motion means change in position with respect to time, with respect to a standard point. That standard point is origin, means origin is reference point. From origin we can observe the position of a particle or position of an event. Means position is always determined with respect to reference point, which is origin. To know the position we require the combination of three axes, means the system of three coordinates. Suppose the coordinates are, now I am taking x1, y1, z1, accordingly these will change, x1, y1, z1, x1, y1, z1. Let an event or an object is at point P when time is t1 and it is displaced or moved to another point Q when time is t2. Then now position vector for position Q, let's take R2, and accordingly the coordinates are x2, y2, z2, and in similar way position vector R2 can be written as x2 I cap plus y2 j cap plus z2 k cap, and this is displacement along a straight line, means shortest path from initial to final position, and time taken by the body t2 minus t1, means when a body is displaced in space or moves in space, means when an event occurs in space, then the coordinates changes, means x coordinate, y coordinate and z coordinate changes, which can be used to express the position vectors of the respective points P and Q. Also, when an object moves from one position to other position, let's say you may imagine a bird is flying in space from position P1 to PQ, then so on. When position changes, the position changes with respect to time, means position changes from P to Q, there will be some interval of time, and time changes from T1 to T2. Thus, an event can be characterized, an event can be described completely by four coordinate systems. Okay, thus an event is characterized by four coordinate system, 3 x, y, z for position and 1 for time. To describe an event completely, we require the combination of four coordinates or system of four coordinates, 3 coordinates x, y, z for position, and another coordinate required is that's called as time coordinate. Thus finally I am repeating my sentence. An event is characterized by 4 coordinate system. The combination of 4 coordinate system is called as space time frame or frame of reference. Okay, let's take this is reference point, means origin. I am transferring the origin to this position. The output of 3 coordinate system means x, y and z are represented along space axis or position axis. And thus only changing the name, let this position is S1 and this position is S2. When the position is S1, time is T1, and when position changes to S2, time is T2. Then accordingly, we may take this is position S1, means from origin distance is R1, this is position S2, this is position S3, and so on. So when position changes, time also changes. Let's take this is time axis. Okay. Time changes. When position is S1, time is T1, position T2, time is position S2, time is T2, position S3, time is T3, and so on. The output of 3 coordinate system X, Y, and Z is represented along space axis. Okay, and the time varies along time axis. Thus, this combination, this is the combination of 4 coordinate system, 3 for position, 1 for time. This is called as space time frame or frame of reference. Okay, this is reference point, and observation should be done with respect to reference point or with respect to origin. Another important thing, the reference point may or may not be at rest. Means the frame of reference may remain at rest or may move. Okay, frame of reference may remain at rest or may move. Okay, this is all about frame of reference. Then I will return to my question what I have asked you. Can a body remain at the state of rest and motion simultaneously? Yes. The body can remain at the state of rest and motion simultaneously. As we have discussed, all conditions of rest and motion are relative. Means relative rest and relative motion. Okay. Let's discuss taking some examples. Okay. The simpler example. Okay. Two general examples. Suppose I am sitting inside the compartment of a train and train is in motion. Okay. I am at rest with respect to an observer. Means observer will observe me with respect to the reference point. Okay. I am at rest with respect to an observer who is sitting in front of me. But train is moving, the observer is moving, I am moving, but I am at rest with respect to the observer. Means with respect to a person, co-passenger who is sitting in front of me inside the moving train. But I am in motion with respect to a person who is standing on the platform, because the person or the co-passenger who is sitting in front of me, he may take reference point inside the compartment of the train. Okay. The person who is observing me standing from platform, he may take the reference point on the wall of the platform. So I am at rest with respect to my co-passenger. I am in motion with respect to the person who is standing outside, means who is standing on the platform. Okay. Suppose we two friends are moving, sitting in a car. Car is moving. Can my friend say me, you are in motion, I am at rest? No. I am at rest with respect to him. But I am in motion with respect to a person who is standing on the roadside. Okay, these are very simple examples. Let's take another hypothetical example. Imaginary example which is not possible at all. Okay? Suppose this is a tree. I am standing near the tree. I am observing the tree. With passage of time, what I observed, the tree is not changing its position. Means the tree is at rest with respect to me. Okay. Now let's consider. Suppose I move to another planet. Suppose I move to another planet. And my eye power is so strong that I could observe the tree on the surface of Earth remaining from another planet. Since Earth is moving, if I observe the tree remaining from another planet, then the tree will appear to move. Since Earth is moving, the tree is also moving. Okay, so these are some very simple examples, maybe hypothetical, but we may think about it. Okay, then about frame of reference, a question on frame of reference, you will think. Okay, before going to the question, I have to first state about the types of frame of reference. Frame of reference of two types. Number one, inertial frame of reference. Number two, non-inertial frame of reference. Frame of reference are two types: inertial frame of reference and non-inertial frame of reference. Let's define. What's the inertial frame of reference? Inertial frame of reference is that this is frame of reference, the system of four coordinates, okay, or combination of four coordinate system. Frame of reference is inertial, which may remain at rest or may move uniformly. We'll discuss in later stage in this subject about uniform motion in simpler way. A body or a system is moving uniformly means it moving with constant velocity. How? Constant velocity means speed is constant, direction is constant. Okay. Frame of reference is inertial. If it is either at rest or moving with uniformly means moving with uniform velocity. Means velocity is constant. Okay. And we know acceleration is rate of change of velocity in simpler way. Acceleration is produced if velocity changes. The frame of reference either at rest or moving with constant velocity. If velocity is constant, there is no change in acceleration. If velocity is constant, then there is no change in velocity. Means acceleration is zero. So, finally we may say, inertial frame of reference is that which either remains at rest or moves with uniform velocity or moves with zero acceleration. Because if velocity is constant, then acceleration is zero. Okay. Then non-inertial frame of reference. Non-inertial frame of reference is that which moves with acceleration. Okay. Try to understand. Non-inertial frame of reference is that which moves with acceleration. Means non-inertial frame moves with variable velocity. Means non-inertial frame moves with velocity which changes continuously. Velocity has both magnitude and direction. Magnitude of velocity is speed. Okay. Again, it has direction. So velocity changes with either change in speed or change in direction or change in both. Suppose a frame of reference is moving towards east. A force is applied along its direction. Frame of reference moving towards east and force is applied on the frame of reference towards east. Then obviously its velocity will increase, means speed will increase. Thus velocity will change, velocity will increase. A frame of reference is moving towards east and a force is applied towards west, means force is applied in opposite direction. Then it is clear that its speed will decrease, means velocity will, magnitude of velocity will decrease. So speed increases, accelerated, speed decreases, retarded motion. Okay, means if force is applied either along the direction of motion or opposite to the direction of motion, the speed changes. Suppose frame of reference is moving towards east. A force is applied on it along north, means at an angle 90 degree. If a body moves along east and force is applied towards north, then its speed will not change, but its direction will change. So, direction of motion will change, means direction of velocity will change. Again, velocity changes, means it is accelerated motion. Okay. Thus, finally, non-inertial frame of reference is that which moves with varying velocity. Okay, or moves with acceleration. Clear? Then my last question about frame of reference or on this lecture. A frame of reference, suppose a frame of reference is moving with acceleration. A frame of reference is moving with acceleration. Suppose this is a frame of reference, position, time. This frame of reference, let this frame of reference is S1, it is moving with acceleration A. A frame of reference is moving with acceleration. Very important question. Does it mean that it is a non-inertial frame? A frame of reference is moving with acceleration. Does it mean that it's a non-inertial frame? Oh yes, yes. Because we have now discussed a frame of reference moving with acceleration is called as non-inertial frame of reference. No. No. Why? We have discussed the state of rest or state of motion depends upon the state of observer and frame of reference of the observer. Okay, let's discuss. Suppose this is the frame of reference S1 which is moving with acceleration A. This is another frame of reference. Position time. Let this frame of reference is S2. This is also moving with acceleration A. I have already discussed. We can imagine frame of reference. Okay. Frame of reference. Suppose this is my classroom. I can use this as a frame of reference because I can get here the mutually three perpendicular axes, x-axis, y-axis and z-axis perpendicular to the floor, and to measure time I can keep a watch. Position time frame, the combination of four coordinate system, and I can keep here watch to measure the variation of time. Okay, I can use this classroom as a frame of reference. I am moving inside the compartment of a train. Compartment of a train can be used as a frame of reference because inside the compartment of a train I can get the three coordinate system x, y, z to determine position. Again I can keep watch to measure the variation of time. Okay. Suppose this is the frame of reference S1 moving with acceleration. Let's consider this is a car moving with acceleration A. This is another car. This is also moving with acceleration A. If I observe, sitting inside this frame of reference means sitting in the cabin of second car. Sitting inside the cabin of second car, if I observe, the motion of first car means frame of reference S1, then it will appear to move uniformly. It will be clear in last part of this motion along a straight line, relative motion. That's I am only telling some lines about it. If two bodies move in same direction, with same speed, means if two bodies move with same velocity, then one body will appear to rest as observed by the other body. If you two friends run along same direction with same speed, then one of you will appear to be at rest to other. Okay, means relative velocity between them is zero. Similar, if two bodies or two systems move with same acceleration, same direction and with same magnitude, then one system or one body will appear to other as moving uniformly or with uniform motion. So, if this frame of reference which is moving with acceleration A is observed from another frame of reference which is also moving with acceleration A, then it is inertial as observed by the frame of reference S1 is inertial as observed from frame of reference S2. Okay. But if a man stands on the road, two cars are moving with same acceleration, means accelerated motion, then for the man who is standing, both are non-inertial. Okay. This is cabin of a car, this is also cabin of a car. I am sitting inside this cabin and observing this car. Then for my observation, this is inertial. If another person is standing on the road, for him, this is non-inertial frame of reference. Okay. This is introduction discussion on kinematics. In next lecture, in lecture 2, I will first discuss in brief different types of motion. Okay, linear motion, translatory motion, curvilinear motion, circular motion, rotational motion, oscillatory motion, vibratory motion, and then I will go to the parameters of kinematics. Okay, thank you, students. Thank you for observing. Again, we will meet in lecture 2. Thanks.